Our topic for today will be about work, energy, and power. Energy is present in the universe in various forms. Every physical process that occurs in the universe involves energy and energy transfers or transformations. Unfortunately, despite its extreme importance, energy cannot be easily defined. Work Work is the measure of energy transfers that occurs when an object is moved over a distance by an external force, at least part of which is applied to the direction of this displacement. So work is a scalar quantity, so it has only magnitude and no direction. Work transfers energy from one place to another or one form to another, and the SI unit for work is joules, the same unit as for the energy. So work is a scalar quantity, so it follows the scalar product of W is equal to the scalar product of F multiplied by delta R. But basically a scalar product follows the rule A, B, cosine theta. Since we have these variables f and delta r, therefore it corresponds with the value of f as f multiplied by delta r cosine theta, which is the derivation of this formula. So take note of the word applied in direction of displacement. So there is no work if the force does not apply to the direction of displacement. Example of this one is this figure. Take note that there are three considerable forces that are applied in the figure. You have our weight and our normal force and its force F. Take note that the forces in your normal force in your weight will not have any effect on the work that would be done by this force F. Because basically this force F can be broken down into its Fy and f of x component. So take note of the word direction of displacement or smooth by the distance, at least part of which is applied to the direction of displacement. The direction of f of displacement is at x direction, which is basically going to the right. And only the force f of x has the x direction that would be used in solving for the work done by the force F. So therefore, in conclusion, the work done by the weight and the normal force is 0, and also the work done by the f of y is also equal to 0. Okay? Force F will do work on a particle only when the particle undergoes displacement in the direction of the force. So, if the particle does not go with the direction of the force, or the direction of the force is not on x direction, if displacement is at x direction, therefore there is no work done. Force or work is just equal to force times distance. Basically, that is the simplest term for work. So important things to know if you are solving the work problem is that the sign of the work also depends on the direction of F relative to the change in R. So if the displacement R or the force does not go with the displacement R, therefore the work done is equal to negative. But if, let's say, ito yung displacement R, mapupunta siya dito, W is equal to negative. But if the force is with the displacement R, therefore work is positive. This is applicable in systems that are basically internal systems like combustions. So when the projection of F onto R is in the direction opposite to the displacement, W is negative. So as I have said, if F is opposite to your R, therefore W is negative. An important consideration for a system approach to problem is that work is an energy transfer. So if W is the work done on a system, then W is positive. And energy is transferred to the system. So if W is negative, energy is transferred from the system. So pag positive yung W, yung ibig sabihin, kayo yung binibigyan ng energy. Pag negative naman, kayo yung nagbibigay ng energy. So, let's have an example for the conceptualizing of the formula. Work is equal to F cosine F multiplied by R cosine theta. So, take note that a block mass of M equals 2.5 kg is pushed at a distance of 2.2 meters. So, this is equal to 2.2 meters along a frictionless horizontal table by a constant applied force of magnitude F. F is equal to 60 newtons. Directed below, theta is equal to 25 degrees. Determine the work done by A, the applied force. So how will we determine the work done by the applied force? So W is just equal to F multiplied by D cosine theta. Our F is equal to 16 newtons, so therefore we will have 16 multiplied by our D cosine theta, which is basically equal to 2.2 multiplied by cosine 25 degrees. So solving for that, we will have a value equal to 16 multiplied by 2.2 multiplied by cosine 25. We will have a value equal to 31.9 31.9 joules. 31.9 joules. Take note that it is positive. Why positive? Because the direction of this force is going with the direction of displacement. Okay. Next, letter B. The normal force exerted by the table. So the work done by the normal force. So take note that the normal force N is at y direction. And the direction of D or the direction of R has nothing to do with the y direction because it is at x direction. Therefore, we have our work done is equal to force, which is equal to the normal force, which is equal to 2.5 multiplied by 9.81, or your normal force, which is multiplied by the distance 0 because there is no displacement, so therefore 0 siya. And then the weight, the gravitational force, which is equal to W, is equal to 2.5 multiplied by 9.81 multiplied by 0, which is equal to 0. Okay? So, as I have said, so I may correct myself at letter B, the normal force, N. So, the normal force will be equal to summation of F of y, which is equal to 0. So, we'll have a value equal to F sine theta. So, going down, it is negative, plus the normal force, less weight, which is equal to 0. So, our N will be equal to W plus F sine theta, which is basically equal to weight, which is 2.5 multiplied by 9.81 plus F sine theta, which is basically equal to 16 sine 25. So we'll have a value equal to 2.5 multiplied by 9.81 plus 16 sine 25, which is equal to 31.28 newtons. But basically, so dito yung normal force natin at letter B tayo. But at B, since wala naman tayong displacement at y direction, therefore W is equal to normal force multiplied by D. But since D is equal to 0, so therefore NF multiplied by 0, so therefore B is 0. Okay? So, pag-erase sa vocabulary niya. Letter C. So the gravitational force, which is basically your weight, is equal to 2.5 multiplied by 9.81 multiplied by 0 is equal to 0. Then letter D, the net force on the block. Determine the work done by the net force of the block. So kukunin natin yung summation natin ng work, which is your work done at A, work done at B, plus work done at C. But since the work done by B and C is equal to 0, therefore, the work done is equal to the work done at A, which is basically equal to 31.9 joules. Okay? Next example. So, a man cleaning a floor pulls a vacuum cleaner with a force of F. So, F is equal to 50 newtons at an angle of 30 degrees with the horizontal. Calculate the work done by the force on the vacuum cleaner as the vacuum cleaner is displaced 3 meters to the right. So, take note of our formula. Work done is equal to F multiplied by delta R cosine theta. So, F, so we have 50 multiplied by cosine 30 degrees multiplied by our delta R, which is equal to 3 meters. So, you will have a value equal to 50 cosine 30 multiplied by 3. So, we have 129.9 joules, or approximately equal to 130 joules. Next, Sheila has just arrived at the airport and is dragging her suitcase on the luggage check-in desk. She pulls on the strap with a force of 190 newtons at an angle of 45 degrees to the horizontal to displace it 45 meters from the desk. Determine the work done by Sheila on the suitcase. So, if you would imagine this one as a particle, and the starting point will be the desk, and Sheila will pull the suitcase at 35 degrees theta with the horizontal at a force of 190 newton until gets out of the desk at 45 meters. So therefore, the work done by Sheila is just equal to work multiplied by F cosine theta multiplied by T, which is basically equal to 190 cosine 35 multiplied by 45, which is equal to 7,003.749 joules, or approximately equal to 7 kilojoule. Next will be Lamar Grant, US powerlifting star, became the first man to deadlift 5 times his own body weight in 1985. Deadlifting involves raising loaded barbell from the floor to a position above the head, which outstretch the arms. So determine the work done by Lamar in deadlifting 300 kilogram to a height of 0.9 meters above the ground. So nakapagtataka yung pivot above the head pero 0.9 meters above the ground. Ibig sabihin, pag mas matangkad si Grant, hindi niya na-lift yung barbell mataas. Okay? So therefore, he lift it only at 0.9 meters. So therefore, if this is the ground and the direction is this position, okay, and his work, pinupull niya siya pataas, so pag ganun yung force niya, the force is going up, okay, and the gravity is going down. Tignan mo lang normal force yan kasi pinupull niya pataas. Yung normal force niya, hindi direkta nakakonekta sa ground. So, this is your, so summation of f of phi equals 0. So, F less W equals 0. Therefore, the force is equal to W. The force of Lamar Grant, which is equal to, W is equal to 300 multiplied by 9.81 meters per second squared, So we'll have a value equal to 900 multiplied by 300 multiplied by 9.81. So we have 2,943 joules. So 2,943 Newton. So work done by the mole grant will be equal to force multiplied by distance, which is basically the distance going up also with the force. So positive yan at 0.9 meters. So we'll have 2,943 multiplied by 0.9. So we'll have a value equal to 2,648.7 joules. This is the work done by Jeremy Blunt. So these four examples are just conceptual problem. Harder problems will be uploaded on separate presentations.